Hi, we're going to start our new unit, which is polynomials. And in this video, we're going to be doing two objectives, and it's going to deal with two objectives. One of them is going to deal with polynomials. Polynomials, and then the other one is going to deal with multiplying monomials. So for the first one, the objective is how do we find the degree of a polynomial and arrange the terms in ascending and descending order. Polynomial is a monomial or sum of monomials. There are different types of polynomials and they have special names. Monomial is one term, binomial, two terms, trinomial, three terms, and polynomial is more than three terms. In the chart below, you'll see different types of monomials, binomials, and trinomials. Notice that monomials is just one term. It could be a number or a number and a variable, a negative number with a variable and an exponent, or a number and different variables next to it. What you notice about them, that there's no sign in between, no like operation like addition or subtraction. So that's just one term. And they're all multiplied to each other. Binomials, you got two terms, and what separates them is a plus sign or a minus sign. And a trinomial is three terms, and what separates them is two operations, whether it's plus plus, plus minus, minus minus. So the first example says state whether the expression is a polynomial. If it is, identify it as a monomial, binomial, or trinomial. So the first expression, it's separated by one operation. There's two terms. Yeah, it is a polynomial. So yes, and the type, since there's two, it's binomial. The next one, is it a polynomial? Look at it carefully. With the polynomial, there's something that is there that you wouldn't see in regular polynomials. This little exponent, this is a -2. So that -2, when you see that in a term, it cannot be part of a polynomial. So in this case, no, and there's no type, and it cannot be a polynomial because you can't have exponents, negative exponents in a polynomial. So I'm going to write no, put this another, yeah, so no negative exponents. All right, the next one. Is it a polynomial? Some of you might say, no, not really, it's a number. Yeah, it's a polynomial. It's just one term. It doesn't have a variable with it, but it doesn't mean it's not a polynomial. It is. And it's only, since it's one term, it is a monomial. And let's look at this one. Is this a polynomial? Yeah, it is. Now, what type is it? Some of you might say, oh, well, there's four terms. Yes, there are four terms, but look what's happening with the two middle terms. You notice that we have 5a and a, they can be combined to 6a. So then that will make it three terms, and so therefore it is a trinomial. Right. So we have two definitions, degree of monomial and degree of polynomial. Degree of monomial is the sum of the exponents of all its variables. So if you have a monomial of one term, look at the exponents that are in that monomial, add them up, and that is your degree. In a polynomial, you have more than one term. You have to look at each of the term and see what the degree is for each of them, and then the one with the highest degree will be the degree for the whole polynomial. So let's do monomials first. The degree, we look at it, 4. For this one, it would be 1, because even though there's not an exponent 1 there, it is implied. And for this one, so x to the first, y to the second, z to the third. So if you add them all up, which I will just do here, oops. So it would be 1 plus 2 plus 3. That'll give us 6. So that is our degree for this monomial. And then for this one, are there any variables next to it? No. So then basically it would just be 0 because we don't have any variables next to it. So the degree is 0. Alright, so let's do more examples. This one says find the degree of each polynomial. So you got to look at each term and count up the exponent for that term. This one, we know it's going to be 0. This one is 5. This one, if you add them all up, 2 and 2, 4, 4 and 3, 7, and this one's 6. So now, since it's a polynomial, let's look at the one that has the biggest number, 7. So the degree for that polynomial is 7. Same thing with number 4. We got 3. This one's 1. This is 1, 1, and 2. This one's the higher number. So then 3 is the degree for that polynomial. So when it comes to the degree of the polynomial, it is the greatest number. The greatest degree will determine the degree for the polynomial. All right, next one. There'll be times where you're going to have to arrange your terms of the terms in a polynomial so that they're in order. For this one, it says ascending order. So that means from least to greatest. So I already took the time to box in the terms, and notice that whatever sign is in front of that term is going to be with that term. So if it's positive, it's going to be with that term, positive, whatever it is. If it's negative, it's going to be negative, whatever it is. So I boxed it up. Now the next thing I need to do is find out what is the degree for each of them. And again, we're doing it in terms of the x. We're looking at the x variable. This one's 2, this one's 4. There's no x there, so it's 0. So now let's look for the highest number. For the highest number, which will be last, and the lowest will be first. So then 0 will be first, and then 2, and then 4. So that term with the 0 will be like negative 11. Then we have positive 7x squared, and then positive 2x to the 4th. Same thing with this one. We're focusing only on the x. So this one, x is 1. There's no x in there, so it's 0. This one is going to be 3. And then this x is going to be 2. Again, you got to pay attention to what they're asking you for, because you don't want to look at the y's. We're only focusing so that the powers are of x in ascending order. So we got 1, 0, 3, 2. And now we just, again, going from least to greatest. So 0, 1, 2, 3. So y squared plus 2xy third minus 3x squared 1, and then plus 5x cubed. Okay, we did this in ascending order. Now we're going to do descending order. Same thing, I already boxed it, the sign with its corresponding term. And we're focusing on the x. So x squared, the 2, there's no x here, 0, 1, and 3. And then we put it in descending order from great to least. So then 3 will be the first one, so negative 2x third, then x squared, 6x squared, and negative 8x, and then 5. Same thing with example 8. Let's focus on the x. So this is be a degree of 2, degree 0, degree 5, degree 1. 5 is the biggest, and we're going down to the smallest, so 5 would be 4x ax to the 5th power, then 3a to the 3rd x to the 2nd, plus 9 to the a second x, and minus a to the 4th. And one thing that I need to specify is that when you go online or when you see in textbooks or wherever, when you see a polynomial from great to least, that's the standard form. So standard form is a polynomial that's going from greatest to least. And then I'm going to specify that it's the degree that's going from greatest to least. So that's the standard form. of a polynomial. Anytime you see polynomial, they always put it in a descending order for that variable, great to least. All right, so we did polynomials. We learned about the different types of polynomials. So now we're going to focus on monomials. So the objective is, how do we recognize monomials and simplify expressions involving powers of monomials? All right, monomial is a number or a variable or a product of a number and a variable or variables. The constant is a monomial that is a real number. So for example, if you have x over 5, your constant is the 1 over 5. That's your constant. It's a monomial that's a real number. Not if you have x over y times x. They're variables. That's not a real number. Unless you substitute both for a number, then it will become a constant, but in this case, it's not. So it says, determine whether each expression is a monomial. So everything is already out in the open. So for this one, they said it's -5. Yes, it's a monomial because it can be a number. P plus Q? No. When it comes to monomial, you cannot add. There's no addition happening. It's either just a number, a variable, or a product. So two numbers have to be multiplied and it will be a monomial. X? Yes, it's a variable. C over D? No, because you cannot divide. There's no dividing or addition when it comes to monomials. It's just a product. And then a, b, c, a, b, c to the 8th power over 5. Yes, because if you were to split it, 1 over 5 times a times b times c to the 8th, it's all being multiplied to each other. So yes, the reason, multiplying. So again, monomials is just either a number, a variable, or a number and variable combined in product form. And the only time you cannot, you have a monomial and it's not a monomial, when you have a monomial that is not a monomial, is if there's an addition happening or dividing. All right. Power. You already have encountered this in middle school. You know the power is an expression in the form of x to the nth power. And in this case, we have 2 as the base, and then the exponent 5, which is up there, the little one. That's just telling you that you're going to take the base and you're going to multiply it as many times as the exponent tells you to do. So you're taking that 2 and multiplying 5 times to give you your answer. So when it comes to product of powers, if you have the same base, then you can add the exponents. So for this one, let's just say if I broke it down, I got 3 2's, and then I'm multiplying it to 5 2's. How many 2's are there? There's 8. So that means your base and then your exponent, you have 2, you're doing this 8 times, so it's 2 to the 8th power. So this is where, again, if you put it in this by step, it will be 2, 3 plus 5, and it gives you 2 to the 8th power. And this is just to prove that, yes, if you were to put this in the calculator, if you were to put 2 to the 3rd and then times it by 2 to the 5th, you will get the same answer if you were to put 2 to the 8th power. So anytime you have the same base, you can add the exponents. You multiply, you have same base and you're multiplying them, add the exponents. So the rule below says to multiply two powers that have the same base, add the exponent. And there's the rule down there. And let's say, for example, you had 2 to the 3rd times 3 to the 5th. You can't add the exponents because you don't have the same base. So when it comes to multiplying powers, if they're the same base, then you can add the exponents. Right, so we just have a few examples. So for this one, we notice that x is the same. So what I like to do is to group the like terms, and then simplify from there. So what I did was I put the 5 and the 1. Again, that invisible number in front of your variable is always 1, so that's the invisible 1. Have 5 times 1, and then times x to the 7 times x to the 6. This will simplify to 5, and then these two have the same base, so I can add the exponent, so that'll give me 5x to the 13th power, so then you multiply, so 5x to the 13th power. This one, again, group the like terms together first when you multiply monomials. So we got the 4 and this negative 7, you got the a to the first, a to the second, and then we got b to the 6th, b to the 3rd. Then you can simplify. This will give you negative 28, this will give you a to the 3rd, and then b to the 9th. So if it's easy for you to do this grouping, do it first, and then you can simplify from as your last and final step. Alright, so when it comes to the power of monomials, this is an example. 4 to the 2nd power to the 5th power. Basically, you're taking that power and multiplying it 5 times. But notice that there's five of this 5 fours, so it's the same base. So you just add the exponents. So they give you 10. So basically, this is what they're showing you. There's 5 2's. You're gonna, and they all have the same base. Then you can add it up and give you 10. Rule is to find power of a power, just multiply the exponents. So anytime you see a power outside of another, raised to another power, you're multiplying it. So 2 times 5, 10. Okay, an example for this one, 3, which is 3 to the 2nd power to the 3rd power to the 2nd power. You're multiplying it, and then you get 3 to the 12th power. And when you see two variables inside of parentheses and it's raised to a power, treat it like the distributive property. But the only thing is you're doing it with exponents. So notice how I took that 4, raise y to the 4th, and then x to the 4th. And then since that's all I can do, that's my final answer. So again, when you have two variables in a parentheses and raised to a power, treat it like you're doing distributive property, but it's for exponents. Right, same thing with this one. You got three factors in the parentheses. Raise each of them to the 3rd. You're basically distributing each of them. So 6 to the 3rd, a to the 3rd, b to the 3rd gives you, and then simplify your number, which would be 216, a to the 3rd, b to the 3rd. There'll be times when you're going to have word problems, especially dealing with like area, perimeter, or whatever the case, but this was area because we're multiplying monomials. They're saying express the area of a square as a monomial. So they gave you the equation, the area for a square, which is side squared. For AB is the sides, they're all the same. So basically you just plug it right in. And then notice that they're all being raised to the 2nd power. So again, doing that distributive property. So you're raising each of the terms, each of the elements by 2. And then you simplify to 4 square, and then you get 16a squared b squared. Right, for this one, make this bigger. It says to simplify an expression involving monomials, make sure that each base appears exactly once. And there are no powers of powers. That means you would have to multiply those powers. And all fractions are in the simplest form. Just like you do with any problems with fraction. You reduce. Alright, so we have our example dealing with that. We got two monomials, and they're both raised to a power. So now, we're going to take this step by step. I made this one blue and then this one red, so that way you can see what's happening between the two. So the first one and the second one, this is what I did. So basically all of the elements in the parentheses are being raised to the 2nd power. So notice that I'm doing that distributive property. So the 3rd is going to be raised to the 2nd, the x and the y to the 4th will be raised. And same thing, well, with this one, you got power raised to a power, you're going to multiply those two. So that will become 6, and the rest will be raised in the blue one. So with this one, I raised each of them to the 2nd power, and then Again, 2 times 3 gives me 6. And notice how it's a power to a power. I'm going to multiply. And this one, each element in that term is going to be raised to the 6th power. So then that leads me to the next step, where I raised each of them, and then I simplified. 1/3 to the 2nd power gives me 9, and this 2x, and then this one, 4 times 2, 8, and then this one is raised to the 6th, and also is y. Now, since I don't have anything to do with this, I just bring it down, but on this one I need to simplify. The -6 to the 6th power, which gives me 46, 65, 6, and then the y gets raised to the 6th. All right. Now remember, when you're multiplying two monomials, so you're going to group them by like terms. So what I did was I grouped the numbers, the constants, together. Constant, remember, is a number. And then I grouped the x's together, but there's only one, so it's by itself. And then I grouped the y's together. When I do that, it makes it easier for me to simplify. So this will become 5184. The x will just stay as x to the 2nd power, and then since I have the same base, I can add the exponent, which gives me y to the 14th. And there you go. It took you from this messy scene to something simplified and clean. So again, make sure that the base appears exactly once. So notice how there was 2 of them, so you're going to have to combine. Since they're the same, you can add the exponents. There's no powers of powers. That means they have to be simplified, either multiplied, or you raised whatever element to whatever power and then simplify, especially if it's a constant. And then all fractions are in the simplest form. We have 1/9, but it times 46, 656, and it turned into a clean whole number, so we're good with that. Right. So there are going to be examples where you're going to have to find the shaded region, an area of a shaded region. Again, you're using everything you know about the area of certain shapes and multiplying monomials. So for this one, this is a rectangle. There's 2 shapes. So you look at it, you see a circle and you see a rectangle. So you're going to take the area of both of them based on whatever information they give you on that diagram. So first one is a rectangle, so a equals bh, base times height. So the base is just b, and the height is, well, they have the radius r, but if you double the r, you get the diameter, and the diameter is going to be the same as the height for the rectangle. So that's why you have 2r. So 2 times r, which gives you the diameter, is also the same as the height for this rectangle. For the circle is a equals pi r squared. Right, so when you need to find the shaded region, you're basically taking this shape and pull it out and leaving a hole in the rectangle. So that's whatever's left over is your shaded area, the area of the shaded region that you're looking for. So in order to do that, you're taking the smaller circle away from the bigger shape, which is the rectangle. So in math form, it's the larger minus the smaller. So the larger is the rectangle minus the circle, which you're pulling out and leaving a hole in the rectangle to find the area of the leftover is your area. And since you can't combine, you leave it like that. So that will be the area of the shaded region, the orange part. Okay, let's do another example. We have, if you look at it, you think, okay, there's 3 shapes. Yeah, there's 3 shapes, but always look for the general shape and then look for the smaller shape. Sometimes you'll have pictures where you have like more than 2 shapes, but in this case, look for a bigger overall and then the small one. So we're looking to find the area of the blue region. So that means we need to pull out that white triangle, and then we're left with those 2 triangles. There's many ways of doing it, but this is the most effective way to do it. Since we have base times height, we don't have any numbers, so we know there's a rectangle, which is base times height, and then the area of the triangle is half base times height. And in order to find the shaded region, the blue part, we're going to take the smaller shape and pull it out from the bigger shape. So then that will be rectangle minus triangle, or BH minus half BH. And since they have the same variables, that mean like terms, you can subtract it. So 1 minus half gives you half, and then you have your terms, BH, and that's the area for the shaded region. And yes, you can find other ways to find the shaded region. If you looked at it as there was 3 shapes, then you would be able to do the area for each of them, and then pull it out. But again, even though if you pull out the white one, you would still have to add up the 2 blue triangles to give you the total shaded area. But this one is effective, easier, less steps, and you get to your answer quicker. All right, I think we've reached the end, so I'm going to do a recap. There was a lot to unpack, so I'm just going back to the beginning without going too far. All right, so you learned about a polynomial, which is the sum of monomials, and there's different types of polynomials. Monomials, binomials, trinomials. Tri is 3, bi is 2, mono is 1. You also learned that with polynomials cannot have negative exponents, or actually, I think though that was only one you negative exponents. So if you see a negative exponent, then you know that no, this can't be a polynomial. And you learned about degree. So for the monomial, look at the variable, the exponent with that variable, and that'll tell you what the degree is. And if you have more than one term, you look at each term, and then the one with the biggest degree is the overall degree for the polynomial. You also learn to put them in order, either from least to greatest or great to least. But when it's from greatest to least, that is the standard form for any polynomial. And that's what you will see if you were to go online or in books or whatever. So greatest to least is a standard form for the polynomials when you're in dealing with degrees. With a monomial, you learn that it can be a number, a variable, or a product of numbers and variables. That means if you see any addition or dividing variables, then it's not a monomial. It's only if you have different factors that multiply to each other, it'll give you a product. So yes, it can be a monomial. And you also learn about constant. Constant is just a real number, a monomial that is a real number. You learned about powers. You learned about base and the exponent. The exponent tells you how many times you're multiplying that base. And if you have the same base and you're multiplying them, the exponents can be added. And power of power. If you have a power that's raised to a power, you just multiply the powers and you have your answer. And also, when it comes to simplifying monomials, make sure that the base appears once. You could have 4, let's say 3 or 4 different types of bases, but it only has to appear once. And then the powers of powers have to be simplified. That means you multiply them, and all fractions, of course, in simplest form. And when it comes to finding the shaded region of 2 shapes, 2 or more shapes, well actually in this case 2 shapes, you're taking the smaller shape and subtract it from the bigger shape to give you the shaded part or the leftover part. Alright, so like I said, there was a lot to unpack. And if you have any questions, you can always email me to get more examples or clarification. Alright, this ends our lesson, and have a good day.